All right, so once again, we're going to look at another way to depict the idea of erosion, but use, again, some different parameters. We used in some of those other erosion videos a proximity to drainage line. In this case, we're going to use another familiar one, the slope conditions. It's probably a safe assumption that areas that are steeper are more prone to erosion. And then we could also say another parameter to use is height relativity. So areas that are maybe kind of lower to the ground have a condition different from areas that are of higher elevation. You could almost even say that areas that are kind of more exposed or kind of these peaks could be vulnerable or susceptible to wind erosion. So again, there's a lot of different kind of takes that you can have on this. And we're going to, again, kind of play with a different style of tiling. In this case, we're actually just going to play with these kind of strands or strips of landforms, as you'll see momentarily. So I'm going to take this surface and I am going to divide it. So again, utility, divide surface. And this is going to give me a grid of points. And again, I can control how dense I want this to be. I'm not going to use a uniform or single slider to affect these because I want to be able to control the densities in a different type of fashion. So again, I'll kind of just play with it a little bit more like this. I don't need it as dense for now. Let's keep it kind of dense in that direction. You can have this maybe a little bit less. Again, you'll see the importance of this soon. So, here's our surface with a grid of points. Like I said, I want to actually have these almost look like kind of these strips of tiling. So if I go to curve and use a interpolated curve, I can connect these points and you'll see that it starts to create these profile curves in this direction, which is it's a good direction to go for now. If you want to have them going the other direction though, you can go to sets, tree, and flip the matrix. So in this case now I'm looking at them this way. And for something that's kind of long like this, I actually want to stick with this direction. I'm not going to actually apply the curve yet. I'm actually going to do something a little bit differently. So we can stick with this. So like I said, we can use two different parameters. I'm going to use them separately, where you can use a elevation one as well as a slope one. I know you guys are hopefully familiar with the slope condition by now from a lot of those other previous videos. So let's just try something different with the elevation in this case. So let's again go ahead and flip this matrix with the points. And what I want to do is go to my vector and deconstruct them. And from here I can get their z values or their heights. And this is going to be, again, our component that dictates everything else. So what's good about this too, I'm going to copy and I'm actually going to flip the UV as well because I do want to evaluate my surface for some other conditions. So I'm going to go to analysis, or I can even just evaluate surface this way. So here's my surface. Here's its UV parameters. You can see that it creates all these different planes going in the different directions. So what I want to do is, let's just kind of reduce the density a little bit for now so you can see it a little bit better. So basically what I want to do is use one of these axes from my planes to control the width of these curves. So let me just show you again. Right, so instead of them just being a single line, they're going to start to have varying widths or thicknesses based off of their height and controlled by this green axis. So we do have to take our frames and deconstruct them so we can draw them appropriately. So the green axis is the y direction, the red is the x, and then it never really shows it, but the z is the blue. So I'm going to go to these frames, so vector, plane, deconstruct plane. So it's actually the frames. And again, I'm going to use the green or the y direction. And again, I'll bump up the density so we can, let's see, let's have maybe 10 in this direction, and we can have a couple more in the other direction. And now I can go ahead and turn this off for now, since I kind of got my visual. So from here, I'm going to start to create some parameters of width. So I can go to curve, line SDL, so the origin is this. The direction is again my y-axis. You'll see that it's starting to go in that direction, but I do want it to go in both directions. So it's kind of like thinking of these as the center line, and I'm drawing from there. So I want to actually copy and paste this and go to math. I guess we can go to vector and just reverse that direction. So I'm reversing my y, and now you'll see that I've got it going in the other direction now. And again, I don't want to have to deal with two line segments, so I'm going to go ahead and join these curves. I'll hold shift to join them. We can turn this off now, and I can even turn this off. So now we can start to see how these are going. And then again, we're going to use our z values to actually depict our length. I like to always kind of create a single slider to just give me some boundaries. So when I look at this, I can see that it's around, let's try 2, 3, we start to get some overlap. Let's try something like 2.5. These are almost nice and pretty close to each other. So this is, so when they're really close, then that means it's going to look like they fracture less, but then anything less than that, they'll have a different condition. So I really just kind of need this as a reference to know that this is probably the max I want to go. I could also tell you that maybe you don't want them to go in these kind of weird directions. So again, I'll give you some other options here. So if I just want these to be nice and horizontal, I can use my horizontal frame. Actually, so in order to do that, I want to go and create my curve off of these points, right? So here's the curve. I can use my curve's closest point. And now use this as my t value. So now you can see that they're all like perfectly horizontal. Again, what's great is we'd still use that green axis. So if if I wanted to, again, I'm just going to copy and paste this. And turn this one off. Now you can see that now my lines just stay perfectly horizontal. It's really, again, kind of up to you on how you want these to respond accordingly. So this one keeps them all like perfectly horizontal. This one kind of goes with the slope in some areas, which creates something kind of interesting. So in this case, let's actually put this one aside for now. And let's just deal with these horizontal ones. And we're going to base it off of, again, the height. So the height of these points or curves is going to dictate how long they get. So again, we need to remap them. Math, remap. So again, we're basing it off their elevation, their minimum and maximum. Go to my favorite graph mapper, so it's not just a simple linear interpolation. Use the Bezier. And in this case, I know, again, my max is going to be 2.5. So let's just go ahead and say that that is 2.5. We can also adjust it accordingly. So again, based off of height, or its elevation, it'll get wider. In this case, we might want it to be the opposite, where the higher, the thinner it becomes. So let's try something like this. So again, I'll show you just kind of looking linear. So you can see areas up here, it's almost, let's at least give it some width, right? So they get really thin. And let's try, and let's actually, instead of just looking at curves, now I can go to surface, and let's turn off my original. And let's go ahead and loft these. Alright, so now, based off of those kind of ridges, we start to see how it gets kind of thin. We can start to play so that maybe maybe they still got some thickness, maybe there's a little more. Maybe it starts to look kind of like this. Creates an interesting kind of tiling where, again, if we were to compare this with the original surface, we can kind of start to see those similarities of like the ridges have these really kind of thin strips. And you can see that based on how many of these curves you have along this will dictate how quickly it might start to change. So if you have less, again, you'll kind of lose some of that resolution. If you change this direction, you might start to have a lot of overlapping. So in that case, let's go back here. Instead of 2.5, let's just go ahead and keep it to 1. Math, multiply, and let's do something like 2.5 again, but I can always decrease it this way instead of having to go all the way into that. And I'll replace these items. So it requires a little more labor, but you'll see that it's not the worst. So now again, I can kind of start to see how they look really flush that way. And let's just go ahead and bake this. And we'll turn off the rest. All right, so it creates a very kind of interesting surface. I'm going to move this over here. So again, like you can kind of see areas that are really low almost look like they don't get affected, versus once they get higher, they do. Let's pretty interesting. And so let's go back to the other style. So maybe instead of elevation, it's based off of the slope. So again, I've got this one that I want to evaluate. So again, what's great that's coming out of this evaluation surface is, again, I've got my direction that I can measure angles. So again, I'm going to, just again, to kind of help you visualize that a little bit more, I'll turn my points on, right? So I'll go to curve, line SDL, the start. It's coming out of this flip because we're just flipping everything. So just imagine these replacing those outputs. Direction, right? So again, they're just kind of going in that Z direction based off of it. Okay, so this again is what we're going to measure. So I can take this normal, find the angle between this direction and the Z direction, give me an angle. And now I can just go ahead and, even though it's in radians, I'm remapping everything, so it really doesn't matter. So let's go to Math, Remap, use the bounds. And again, so if it's almost perfectly flat, it's going to have very little angle. If it's steep, it's going to have a lot of angle to it. So again, let's adjust it this way. Remember that we've got our curves going in these really crazy directions. Let's again reduce it. Well, we can keep it this way, but maybe they're around 10 as well. So you'll just see that our kind of strips get a little more kind of whimsical, so to speak. So let's turn this off. Oops, not disable it. Preview, so that's what it looks like. And again, based off the angles, we can assign different lengths for this. So parameters, input, graph mapper, graph type is going to be Bezier. So again, I know the max is 2.5, so let's just go multiplier, 2.5, and that will replace this. So again, the steeper it is, the wider, in this case, the wider it is. So maybe again, we want to invert this. I mean, let's see what this looks like first. So again, I'm just going to go to surface and loft these. Right, so they got more angle to them instead of them just being kind of horizontal. So in this case, again, based off of how steep it is, maybe I want them to be narrower. So let's just go ahead and flip this. Maybe they have some thickness to them still. So it's a little more difficult to decipher, but you get the point. We can again kind of give it a little more density in this direction. Maybe a little more that way, and then we can just change this to be a lower value so it's not overlapping too much. Right, that kind of looks pretty cool. So again, this one, it's not totally different than the height, but we can see areas that are just steep, not necessarily height, are what give you the most variation. You know, what's really cool, you'll probably make it look a little messy, but let's see what happens if I kind of keep all of this, except maybe I don't flip it. So I'll just copy and paste, move it down. And actually, I don't need that. This is the only area I'm flipping it, so let's see what happens if I just go like this. And the only other thing I need to change is that now they're going in the other direction. So instead of it being Y, it's going to be X. So let's just go ahead and replace these. And now we can make that much denser as well. So you can see that if I turn this part off, it's just a lot less dense. So let's do more in this direction. And then less in this direction. Let's try something like 10. Let's just make these nice even numbers. And we'll turn it off and just go ahead and bake them. All right, that creates a really crazy kind of weaving pattern now, which is pretty interesting. I wasn't expecting that, but pretty happy with it. So here's again kind of two new ways of creating that interesting erosion factor.